Hello and welcome to another complete mathematics video brought to you by LaSalle Education. This tutorial video will help pupils work out the equation of a line given 2 points. Pupils should already be familiar with using y equals mx plus c, where m is the gradient and c is the y-intercept. Pupils should be comfortable calculating the gradient of a straight line, and by the end of this video we'll hopefully be able to work out the gradient of a line given any 2 points. So let's start with an example. Here we have an xy coordinate plane. 2 points are marked. 2 points can be joined with a straight line. The first point I'm going to label A. A is going to be represented by the coordinate pair x1, y1. 2, 6 gives the point. The second point, B, is going to be represented by the second coordinate pair, x2 and y2. This has the value 4, 10. Pupils will be familiar with calculating the gradient. Gradient gives us the slope of the line. If it's positive, negative, we can calculate it using the change in y divided by the change in x. The difference between the y values can be calculated with y2 minus y1. The difference in the x values, x2 minus x1. This will give us the slope of the line. Substituting values for y2 and y1, x2 and x1, we can calculate the gradient as being 2. We should be familiar with the equation of a straight line as y equals mx plus c, and we can replace the m in this equation with our calculated value for m of 2. We now need to calculate the value for c. C is going to be the y-intercept. Now in this case we actually have the graph and we can see that we're looking to get an answer of 2. However, let's substitute our coordinate pairs and see if we can get to that answer. I'm going to substitute x2 and y2 first. So the y2 value is 10, is 2 lots of the x value plus c. 10 is 8 plus c, and hopefully you can recognise that c would equal 2. If I substitute the first coordinate pair, my y value would be 6, and that would be 2 lots of 2 plus c, and again we can see that c would equal 2 as per our prediction. So to write this in the form y equals mx plus c, I can write y equals 2x plus 2. Here's an example for you to try. Why not pause the video and have a go? I've already labelled x1, y1, x2, y2 for you. Pause the video. Let's work through the solution. We need to calculate the gradient using the change in y divided by the change in x. y2 minus y1 is 7 minus 1. x2 minus x1, 4 minus 2. We have a gradient of 3. Substituting into y equals mx plus c, we can change the m to our calculated value of 3. We're going to substitute one of our coordinate pairs to find the value for c. 7 is 3 lots of 4 plus c. 7 is 12 plus c, and hopefully you can see that c has a value of negative 5. To write this as an equation, y equals 3x minus 5. If we substitute our first coordinate pair, we can check whether that is actually going to be the same. So I'm going to replace the y with a 1, and I'm going to replace the x with a 2. 1 is equal to 6 minus 5. That's correct. So yes, our equation was y equals 3x minus 5. Hopefully that's what you got as well. But what about if we don't have a coordinate grid and we only have the 2 points? Well, to start with, we could sketch a diagram to see what the graph might look like. -5, 10 would be over here. 3 minus 7 would be over here. 2 points can be connected with a straight line, and we can see that the gradient would be negative. So let's see if we can calculate what the equation of that line is. We're going to label our coordinates x1 and y1, x2 and y2. It's always important to make sure we label our coordinate pairs. Our gradient is still our change in y divided by our change in x. y2 minus y1 minus 7 minus 10 divided by 3 minus -5. We end up with minus 17 over 8. This looks a bit trickier than last time. Let's see if we can simplify that to a mixed number fraction of minus 2 and 1/8. We know straight lines have the equation y equals mx plus c. And we can replace our m with our calculated value of minus 2 and 1/8. Now we need to substitute in one of our coordinate pairs. So the first value we're going to put in is our y value. Y is going to be 10. So hopefully we can see that we've used our y1 value. So we're going to need to replace our x with our x1 value. That was -5. Minus 2 and 1/8 times by -5 gives us 10 and 5/8. At this point, we should be able to see that c is equal to -5/8. To write in the form y equals mx plus c, we have y equals minus 2 and 1/8 x minus 5/8. We can check that by substituting our second coordinate pair. Minus 7 equals minus 2 and 1/8, lots of 3, minus 5/8. Minus 7 is minus 6 and 3/8, minus 5/8. And you can see that this does indeed hold true. So our equation would be y equals minus 2 and 1/8 x minus 5/8. Here's one for you to try. Pause the video and have a go for yourself. We'll then work through a work solution. Time to pause the video. Hopefully you drew a sketch to show where the 2 points are. You can see that they can be connected with a straight line, and this time it looks like we have a positive gradient. So we're going to label our points x1 and y1, x2 and y2. These are our coordinate pairs. Our gradient is going to be calculated using the same change in y divided by change in x. We can do the change in y by y2 minus y1 divided by x2 minus x1. Substituting our values, 13 take away 1 divided by 2 minus -2 gives us 12 over 4, which gives us a gradient of 3. Substituting into y equals mx plus c, we now have y equals 3x plus c. Substituting in a coordinate point, so this time I've used y2 and x2, we can calculate that c has a value of 7. We can check that with our second point. And indeed, c has a value of 7. It doesn't matter which of the coordinate points you use, as long as you use the x and y value from the same coordinate pair. We can write this as an equation, y equals 3x plus 7. Thank you for watching. Look forward to seeing you in our next video.